Hi guys, for today, we will be discussing several examples of Gauss's divergence theorem. So in all of those examples, we will apply this theorem to compute for fluxes of fluids. Pero first, let's recall the statement of Gauss's divergence theorem. Ano yung kailangan natin for this? Number one, we need a closed and bounded solid G in R3. Tapos apart from this bounded and closed solid, we will also need the surface S, the boundary surface S of G. In other words, itong surface na to, this should enclose G. Okay? And then apart from these two, we also need a vector field F whose partial derivatives are continuous. So yung components niya, dapat continuous yung kanyang first partial derivatives. Then what does Gauss's divergence theorem tell us? It tells us that this surface integral of F over this surface S, it must be equal to the triple integral of the divergence of F over the solid G. So what will this tell us? This should tell us na instead of computing outright for the surface integral here, we can instead go through this triple integral. Kasi most of the time, hindi natin alam yung parametrization ni S, no? Or kung alam man natin yung parametrization niya, it has a more difficult equation. So instead of considering the surface S, i-consider natin instead yung solid G that it encloses. Kasi sometimes it's easier to work with solids than with surfaces. So this is convenient in many cases. Now take note, itong n na to, this just denotes the outward unit normal vector of S. Kasi remember, we have a condition on S na kailangan orientable surface siya. Okay, let's proceed with our first example. Let's find the flux of the fluid with this velocity field across the closed cylinder x squared plus y squared equals 1 between these two planes. So let's first sketch the surface in question. So ito yung three-dimensional space natin. The plane z equals 0, di ba? That's just the xy plane. So drawing natin yung xy plane, it's this one. Tapos you move upwards along the z-axis by 3 units, you should get z equals 3. So itong red surface na to, itong red plane na to, this is now z equals 3. So these two are taken care of. Yung cylinder x squared plus y squared equals 1, what does that look like? Remember, itong curve na to in 2 dimensions, this is a circle centered at the origin of radius 1. Tapos kapag pinatong niyo siya on the xy plane, it should be this one. Tapos itong black na curve na to, remember it's between the planes z equals 0 and z equals 3, no? So to get the entire cylinder, itong circle na to, let's move that upward until we get to the plane z equals 3. So we move that until we stop at this point so that yung surface in consideration natin, it's now this one. So ito yung surface na kailangan natin. So let's now set up the integral that we need. By Gauss's divergence theorem, yung flux, which by definition is equal to this surface integral of f over s, it's equal by Gauss to the triple integral of the divergence of f over the solid g enclosed by this surface here. So in this case, yung g natin is this cylindrical solid, no? Itong right circular cylinder na to. Okay, so if you were to compute for this conventionally, ano yung kailangan nyong gawin? You'd have to separate this surface into 3 subsurfaces, no? So you have these two bases here. Those are 2 separate surfaces. Tapos meron pa kayong lateral part ng cylinder. That's another surface. So you would have to compute for 3 separate surface integrals and add them to get the flux, no? However, if you use instead itong triple integral na to, you will have a much shorter solution, which we will see later. Okay, first let's compute for the divergence of f. By definition, ano yung divergence? It is the partial of the first component with respect to x, plus the partial of the second component with respect to y, and then plus the partial of the third component with respect to z. So remember, by definition, yung divergence ng isang vector field, it is a scalar field, no? So scalar functions tong tatlong to. In contrast with the curl, yung curl ng isang vector field is isang vector function. So this is a scalar function. Just take note of that when you're computing for the divergence. Let's now compute for each of these partial derivatives here. For the first term, si x plus y plus z. Yung y plus z natin, di ba, constant yan with respect to x. So both of these, their derivatives with respect to x, they're both 0, no? Tapos kapag dinifferentiate nyo si x with respect to x, you should get 1. So this one, its derivative is 1. And then plus yung partial derivative naman ni y with respect to y, that's again 1. So this will give you a 1 again. And then plus yung 2x minus y, as you can see, this will have no z variable, no? And when you differentiate this with respect to z, you will get entirely 0. So you have here 1 plus 1 plus 0. Yun yung integrand natin. And then of course, 1 plus 1 plus 0, that should give you 2. Yung 2, constant yan. Labas natin dun sa integral. That should give you now twice the triple integral of dv over g. Pero let's recall, ano nga ba yung interpretation natin geometrically nitong quantity na to? This should give you exactly the volume of g, no? So in other words, yung flux natin, it's now twice the volume of g. And ano nga ba yung g natin? Yung g is this right circular cylinder, no? And we know how to compute for the volume of a right circular cylinder. It is just pi times the radius of the base squared and then times the height of the cylinder. In this particular example, ano yung base natin? Yung radius niya ay 1, no? And then yung height ng cylinder natin is 3 units. Kasi from z equals 0 to 3, yung distance nila ay 3. So kapag nag-compute na kayo ng volume, it's now 2. And then times pi, and then times the radius squared is 1 squared, and then times 3, yun yung height ng ating cylinder. So kapag nag-evaluate na kayo nito, when you simplify this, you should get 6 pi. So the flux over this surface here is just 6 pi. Okay, next example number 2. Let's again find the flux of the fluid, this time with this velocity function, across the surface S consisting of this paraboloid over here below z equals 1, and enclosing the circular disk which is on the plane z equals 0. So let's sketch first the surface S. So kapag nag-sketch kayo ng circular disk natin, ano nga ba yung itsura nito? It is a circular disk of radius 1, kasi 1 yung right-hand side, centered at the origin, you should get this. Tapos remember, z equals 0, that condition should tell you na itong disk na ito nakapatong dito sa z equals 0. However, what's z equals 0? That's precisely the xy plane, no? So, itong disk na to, nakapatong dapat siya dun sa xy plane. Okay, so okay na to. Let's now sketch the paraboloid z equals x squared plus y squared. Ano nga ba yung graph niyan? So, kapag nag-consider tayo ng traces, if you set the trace on the xz plane, you set y equals 0, no? And in this case, you get z equals x squared, which is a parabola of vertex at the origin. Tapos dapat yung kanyang 2 points on that parabola are somewhere here, itong point na to. Tapos ito yung isa pang point on the parabola. Tapos for the yz plane naman, when you set x equals 0, you will get something similar, no? So that when you sketch the paraboloid, you should get something like this. Tapos again, we're given here the condition that this paraboloid must be below z equals 1, no? So itong part na to, itong top ng ating paraboloid, that's now your cut of z equals 1. You should not go above that. And finally, when you now consider the surface S, dapat ito yung maging solid natin. This is the surface S that we are considering. So this should sort of look like a cylinder. Okay yung baba, however yung taas para nakaumbok siya pababa, no? So ito, ibig sabihin nito dapat we should convert at some point into cylindrical coordinates, no? To have a shorter solution. We will convert them later. But first, let's set up the integral that we will need. The flux, so again, by definition, it's just this surface integral over here, no? Pero by Gauss's divergence theorem, this surface integral must be equal to the triple integral of the divergence of f over the solid g enclosed by this surface over here. And when you now compute for the divergence, what should you get? You should get yung partial nito with respect to x, plus yung partial nito with respect to y, and then plus yung partial naman nito with respect to z. Let's compute for all of those partial derivatives. So for this one, when you take its partial with respect to x, what should you get? So for the first term over here, yung y lalabas, no, with respect to x, multiplied by the derivative of tangent inverse of x with respect to x. Ano yung derivative na yon? It is 1 all over 1 plus x squared, no? So you have y times 1 over x squared plus 1, of course, you get y over x squared plus 1. And then plus derivative ng cosine x with respect to x, that should give you negative sine x, no? Okay na tong dalawang to. Ito naman with respect to y, what will happen? So yung sine x lalabas with respect to y, no? Derivative ng y is 1. So sine x times 1, you should get positive sine x. Okay na to. And then plus for this one, when you differentiate with respect to z, yung z squared, magiging 2z, no? So 2z to. And then minus with respect to z, yung y over x squared plus 1, lalabas yan. Times derivative ng z, you should get 1. So all in all, your partial derivative with respect to z is now 2z minus y all over x squared plus 1. So ito yung partial derivative na to with respect to z. And as you can see, when you simplify this, meron dapat mga magka-cancel, no? So in particular, yung y over x squared plus 1, this will cancel out with a negative here. They will cancel out. And then negative sine x plus sine x will also cancel out. And that leaves you now with a triple integral of 2z over the solid g. Now, like I mentioned before, itong triple integral na to, it would be more convenient to convert that into cylindrical coordinates to evaluate. So let's compute for that. So in cylindrical coordinates, let's convert all of the surfaces here. Yung z equals x squared plus y squared, when you convert that into cylindrical, remember in cylindrical, yung z mananatili yan, no? Z will not be changed in cylindrical coordinates. Yung x squared plus y squared in cylindrical, remember, what's that equal to? It should be equal to r squared, no? So yung cylindrical equation nitong paraboloid is just z equals r squared. Tapos itong circular disk na to, yung x squared plus y squared less than or equal to 1, ito ay r squared less than or equal to 1. Pero since yung r ninyo ay positive, you should get r to be less than or equal to 1. So yung equation nito is r less than or equal to 1. Okay? So yung flux natin in cylindrical coordinate, it's now the triple integral of this one converted to cylindrical. Pero 2 is of course constant. Yung z hindi yan magbabago in cylindrical. So we will retain the same integrand which is 2z. And then yung dv natin, what will that turn into? It will now be r dz dr d theta. Remember kapag cylindrical coordinates, meron tayong butaw na r dito sa labas, no? So you should have an r in cylindrical coordinates. And then all we have to do now is to determine the limits for z, for r, and for theta. So for z, ano yung gagawin natin? We consider yung solid kanina, no? And then we look at the lowermost portion of that solid. Yun yung magiging lower limit natin for z. And then you move upwards until you get to the uppermost portion of the solid. That should give you now the upper limit for z. Now remember, what's the lower limit in that particular example over there? Yung lower limit natin, di ba, it's the circular base. However, yung circular base natin kanina, balikan lang natin yung surface, it's precisely lying, no, on the xy plane. So this base over here is exactly part of the xy plane. So yung equation nitong part na to is z equals 0, yung surface na yon. So what's your lower limit now in z? Your lower limit in z is just z equals 0. And then you move upwards until you get to the paraboloid. That's now the upper portion of the solid there. And ano yung cylindrical equation ng paraboloid? It's precisely z equals r squared. So yun yung upper limit ng ating z. Okay na yung z. Let's now consider dr and d theta. So for dr and d theta, let's now consider yung projection ng solid onto the xy plane. And then to get the exact limits, yung gagawin natin is like what we do in polar coordinates, no? So I'll elaborate that later. Now remember, this is the solid, tama? When you project that onto the xy plane, you should get this circular base over here. And then this circular base, that will now give you hints, no, on how to determine the limits for r and the limits for theta. So to get the limits for r, what do? Essentially, you start with a line from the pole extending onto the surface, or not the surface, rather the region. So you start with the pole, and then you extend onto the region. Yung unang part ng region na tatamaan niya, yun yung magiging lower limit ninyo for r. Tapos yung huling part ng region na tatamaan niya, yun yung magiging upper limit ninyo for r. Now in this particular example, di ba, we started at the pole. Yung pole ninyo, part siya ng surface. So tatamaan ng surface yung pole na to. So that will be your lower limit. And remember, yung polar equation ng pole, di ba, that is r equals 0. So your lower limit for r, it is r equals 0. And then from the pole, you extend to the region until you get to this portion of this circle here. Tama ba? So ibig sabihin, since ito yung huling natamaan ng radial line na yun, this should be your upper limit, itong circle na to. Pero remember, this is x squared plus y squared equals 1, di ba? Yung kanyang polar equation is r equals 1. So yung upper limit natin for r, that is now r equals 1. So your limits for r, this is r from r equals 0, papuntang r equals 1. So yun ang magiging limits natin for r. And then finally, for theta naman, anong ginagawa natin? Yung radial line na dinrawing natin, we rotate that until we consider the entire surface. So in particular for this one, kapag nag-rotate kayo ng radial line, so rotate tayo until kapag na-consider na natin yung buong region, we stop here. So we started at 0, yun yung lower limit natin for r, or rather for theta, sorry. And then you rotate that until we get to this portion of the region. Pero ano nga ba to? This is now theta equals 2 pi. So, laging ganun, no? Kapag full circle tayo, it's always from 0 to 2 pi. Kapag meron kayong circle centered at the origin, the limits for theta are from 0 to 2 pi. So, just to recap, the limits for z are from 0 to r squared, from the base to the paraboloid. Yung r natin is from 0 to 1, and then yung theta natin is from 0 to 2 pi. So, ito na yung iterated triple integral na kailangan nating i-evaluate. And again, how do you evaluate an iterated triple integral? You start with the innermost, no? So for the innermost integral, you're integrating with respect to the variable z. So all variables that are independent of z, lalabas sila dun sa integral na yon. And in this case, ano yung lalabas? Yung 2 pwede nating ilabas. Yung r pwede nating ilabas, no? Kasi independent siya of z. And in this case, yung r yung ilabas natin. Let's integrate 2z with respect to z. We have now the integral of r, and then ano yung antiderivative ng 2z with respect to z? So you get 2 times yung z magiging z squared all over 2, no? Tapos yung mga 2 magka-cancel out, and that leaves you with z squared. So this is now r times z squared, and then you evaluate from z equals 0 papuntang z equals r squared. So for convenience, always indicate the variable that you're replacing with, no? In this case, you're replacing z with 0, you're replacing z with r squared, okay? So this is now the antiderivative that we have computed. Tapos ano yung matitirang integration natin? It's now with respect to r and with respect to theta. So ito na yung iterated integral na kailangan natin computein. Pero first, let's compute for this. So for z squared, when you evaluate z at r squared, you will get r squared quantity squared, no? In other words, you get r to the 4. And then minus, when you evaluate this at 0, of course, you get 0. So you get r to the 4 minus 0, you should just get r to the 4. So you have r times r to the 4. And then when you multiply these two together, you should get r to the 5th. And then all that's left to do now is evaluate this iterated double integral, no? So let's evaluate this next. Ano yung antiderivative ng r to the 5 with respect to r? Anong ginagawa natin? Yung 5, you add 1 to that. You should get r to the 6. And then divided by that same exponent, 6, no? So you get now the integral from 0 to 2 pi of r to the 6 over 6. And then for this one, you evaluate from r equals 0 hanggang r equals 1, and then d theta. Now for this one, when you set r to be equal to 1, you get 1 to the 6 over 6. Of course, that's 1/6. And then minus 0 to the 6, that's 0 divided by 6, you again get 0. So you get 1/6 minus 0 over 6, so you get just 1 over 6. And then yung 1/6, lalabas yan, leaving you with 1/6 times the integral from 0 to 2 pi of d theta. You should get 1/6 times 2 pi minus 0, or 2 pi. And then when you simplify this expression, you should just get pi over 3. So the flux here, it's now equal to pi over 3. Okay, next 3D example. Let's now determine the flux of the fluid with this velocity function across the boundary surface S of the tetrahedron bounded by the 3 coordinate planes and this plane x plus 2y plus z equals 2. So let's sketch that solid in 3 dimensions. So to sketch yung plane natin, anong ginagawa natin? Normally, we look for intercepts, no? So for instance, to look for the x-intercept, you set y and z to be equal to 0, no? So you get x plus 0 equals 2. You get x equals 2. Yun yung x-intercept natin. And then for y, similarly, you set x and z to be 0. So 0 plus 2y plus 0 equals 2. So 2y equals 2. Divide by 2, you get y equals 1. And then finally, for z, when you get intercepts, you get x and y to be 0. Itong dalawang to mag-0 plus z equals 2. You get z equals 2. So in other words, yung x-intercept natin is 2. The y-intercept is 1, and then the z-intercept is 2. And then when you now sketch the entire plane, it should look like this. Itong blue plane na to, yung x plus 2y plus z equals 2. So yun yung solid in consideration natin ngayon. Okay, let's now set up the integral that we need. Again, by Gauss's divergence theorem, yung flux, it's equal to this one, no? And then when you complete for the divergence, it's the partial of the first with respect to x, plus and so on. Tapos kapag nag-compute ng mga partial derivatives, for instance, this one, yung y lalabas, derivative ng x squared with respect to x is 2x, no? So you get 2x times y, you get 2xy. Ito, yung x lalabas, yung y squared derivative is 2y, no? So x times 2y, that should give you 2xy again. And then plus yung 2xy lalabas with respect to z. And then partial ng z with respect to z is 1. So 2xy times 1, that should give you again 2xy. So you have 2xy plus 2xy plus 2xy. That should give you now 6xy. So ito yung integral na kailangan natin computin, no? And since we're given here your solid G to be the tetrahedron enclosed by the boundary, we have to retain this in rectangular coordinates. Okay, let's now determine the limits of integration with respect to variables, no? Okay. Let's start first with respect to z kasi in this case, yung base ng solid natin, it is parallel to the xy plane, no? In fact, it's on the xy plane. So with respect to z, ano yung gagawin natin? Like with the previous example, remember, we start at the lowermost part of the solid, no? And then you move upwards until you get to the uppermost portion of the solid. So those two will determine your limits of integration. So for instance, with respect to z, ano yung lowermost portion ng solid natin? It's this triangular base, no? And itong triangular base natin, di ba, nakalapat siya exactly on the xy plane. So it's part of the xy plane. So its equation is just z equals 0. Yung lower limit natin is 0. And then you move upwards until you get to this blue plane here. Pero remember, what's the equation of the blue plane? It's x plus 2y plus z equals 2. Tama ba? Pero take note, we're integrating here with respect to z. So kung with respect to z, we have to isolate z on one side, express the rest in terms of the remaining variables. So in particular for this, you have x plus 2y plus z equals 2. Yung z isolate natin on one side, transpose the rest on another. So you should get z equals 2 minus x minus 2y. So yun yung magiging upper limit natin for z. Okay na yung z. Yung dy and yung dx, how do we determine those limits? We basically consider yung base naman ng solid, no? Or in general, yung magiging projection ng solid onto the xy plane. So let's consider that projection. So ito yung projection natin. And take note, itong diagonal line na to, it has equation y equals negative 1 half x plus 1, no? Kasi yung magiging y-intercept natin, it's 1. So the constant is 1. And then you can compute the slope. It should be equal to negative 1 half. So negative 1 half x plus 1 yung equation na itong line na to. Okay, let's now determine the limits for y. So for the limits for y, anong ginagawa natin? We essentially determine the lowermost curve in this region, no? That will be the lower limit for y. And then you move upwards until you get to the uppermost portion of the region. That will determine the upper limit for y. So for dy, ano yung lowermost portion ng curve natin? It is just y equals 0. Tama ba? Kasi x-axis yun, no? So the lower limit is 0. And then from here, you move upwards until you get to this line over here. Pero remember, itong line na to, di ba, its equation is negative 1 half x plus 1. So this is now your upper limit in y. It's now 1 minus x over 2. So that's the upper limit for y. So, okay na yung y. Ano yung gagawin natin to determine the limits for x? This red line over here, let's make that move from left to right. So, in this case, itong red line na to, if you make that move, you start from the left at this portion here. Pero this portion here, what is the equation of that? It's x equals 0. It's x equals 0, no? Kasi you're starting at the y-axis, its equation is x equals 0. So, your lower limit for x is 0. And then from there, you move to the right until yung dulong-dulo is this one, no? And ano yung coordinates nitong point na to? It's precisely 2, 0. And since you're integrating with respect to x, you retrieve the x coordinate of that point. Yun yung magiging upper limit natin. So the upper limit is now 2. Okay, and then I won't show the solution further kasi medyo mahaba yung computation nitong triple integral na to. Pero you can check that this triple integral should evaluate to 2/5. So 2/5 yung ating integral over here.